Hello mathematicians, let's get started. We've got another proof by induction, and today we're going to be showing that the sum of 1 over some series of numbers squared is going to be less than 2 minus 1 over that many numbers. So just to give us some practice with sigma notation, and pay attention because this is going to pop up again later just because I kind of run out of room. We've got from starting with j of 1 going all the way up to n. We've got the sum of 1 over j squared. And this is a really interesting problem because before we've been showing like that this is equal to something, right? This is just showing, which one is going to be bigger. And that's what this helps us solve, is which number is going to be bigger. And really from that we can say, is it always going to be bigger? Is this always going to be bigger? And I think it's a very interesting problem. So let's dive right in, and recall that I always like to start with proving or stating a goal, right? So remember, proofs by induction are officially a two-step process. You prove a base case, then you have your induction step. I like to think of it as a four-step process where we first state our goal, and our goal is going to be to prove the above conjecture. Alright, that's pretty much always going to be our goal. We're trying to prove some conjecture. We have a theory, and now we need to actually test it on some places. And to do that, we're going to show that 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus all that other stuff plus 1 over k squared plus 1 over k plus 1 squared, all of that should end up being less than 2 minus, 1 over k plus 1. Alright, so that's what we're trying to show. This is our goal, right? This is what we're trying to prove, essentially. So let's always remember to keep that in mind as we work through the rest of this process. Now, step 2 is usually quite simple. This one's got a very interesting thing that we might not have seen before for step 2. Our step 2 is going to be the official step 1, where we prove a base case. And I forgot to write on the first page, we're only dealing with integers here, right? We're starting with the positive integers. So let's see what happens if we start off with p of 0. Because I think if anytime we can use a 0 or a 1 as our base case, that's beautiful because the algebra just kind of shakes away at that point. So let's try it. We've got 1 over 0 squared. Wait a minute, this is going to be a divide by 0 thing, isn't it? And it's even worse than that, because then I come over here and I say 2 minus 1 over 0. So this whole thing is just undefined. This isn't any good. So let's try for p of 1. P of 1 should work a lot better. Let's double check. We've got 1 over 1 squared, which is just 1. All of that shakes out to 1. And is that going to be less than 2 minus 1 over 1? Well, that's just 1. We just said that. So this is really equal to 2 minus 1. So is 1 less than 1? No, it's not. It's equal to 1. 1 is 1. 1 cannot be less than 1 if it is 1. So this doesn't work. So this might be something new we might not have seen yet, is that our base case, is a little bit higher than 0 and 1. Let's try another one. Let's try it for 2. Low numbers are always easy to work with. So we got 1 over 1 squared plus 1 over 2 squared. And we're trying to see if that is less than 2 minus 1 over 2. Alright, so over here we've got 1 plus 1 over 4. We're trying to see if that is less than 2 minus a half. Well, if we add these up, we're going to get, 1 1/4, 1.25. And is that less than, well, what's 2 take away a half? That's going to be 1 1/2. So can we see, is 1.25 less than 1.5? As far as I'm aware, this is true. This is a true statement at this point. Now we kind of had to leave the wonderful world of integers, but that was fine because our original problem had fractions all over the place. So we found our base case. We found a base case for n, what do we want to say, greater than or equal to 2. If you want to say for n greater than 1, that's fine. Either way you like to write it will be perfectly acceptable. So let's move on to step 3 of the process. Now remember, this is officially the start of step number 2 of our induction step. We're going to assume P of k. So what does that mean? That means we get to assume that for a P of k, that this propositional statement is going to say 1 plus 1 over 4 plus 1 over 9 plus all that other stuff plus 1 over k squared is going to be less than 2 minus 1 over k. Alright, so this is our assumption step, right? We're allowed to make this assumption. It's a mathematical leap of faith that there is some point where this statement is true. It's a very safe assumption to make because we've already shown in our base case that there is a spot where this is true. It's a very safe assumption to make. But now comes the tricky bit. Step 4, the second half of our induction step. We're going to show that P of k implies P of k plus 1. Now, so that's what we're trying to show. And we'll hopefully, ideally, end up with something that shows that 1 plus 1 over 4 plus 1 over 9 plus all that other stuff plus 1 over k squared plus 1 over k plus 1 squared is all going to be less than 2 minus 1 over k plus 1. Now, at this point, we have to be a little creative with how we approach the problem, right? Because we're dealing with an inequality, so we just need to show that this statement is true for some spot. And that can really help us out. We can really use that feature to our advantage. So I'm changing colors here for just a moment. So to consider this, we know that this bit, right, this is the sum starting at 1 to k, or 1 over j squared, is less than 2 minus 1 over k. Alright, so we know that. And we know that because we assumed it to be true, right? We showed there's some mystical spot we don't really know where this statement is true. But notice this. Let's change colors again. If we take our handy dandy blue pen now, the only difference from this appears to be this bit right here. So if we were to take that and add it to both sides, that should be the only difference is that right there. So why can't we say that? Why can't we say that the sum with j starting at 1 going up to k plus 1, where 1 over j squared is going to be less than 2 minus 1 over k plus that 1 over k plus 1 squared. This is all we're changing. I'm pulling this from here. Hope everyone can see where this value came from. It came from here. And all of that, we've said, since we said this is, equivalent, all of that is going to be less than 2 minus 1 over k plus 1. So if we can show that, then we've got our proof. If this bit is going to be less than this bit, and this bit is less than this bit, well, that's what we showed. This is going to be less than this. Just transitive properties at work. So how can we take it from here? Well, there's a couple of different approaches. But because I'm working off a script, I did all this off camera just before recording. I happen to know a way that works really, really well. So I encourage you to try to experiment on your own, but I happen to know a way that works really well. Let's pull this back over. Now let us factor out a -1 from 2 minus 1 over k plus 1 over k plus 1 squared. From this bit. Let's pull out a -1. Well, I hear you say, Mr. Gillenwater, there's no -1 there. So we'll have to kind of work that trick where we multiply a thing out where we can factor it. Not a complicated algebraic trick, but it's something to kind of be aware of. So I'm just going to rewrite our problem first. Starting a new page, it's usually a good idea to rewrite your problem. So we got 1 minus 1 over k plus 1 over k plus 1 squared. And I said we wanted to factor out a -1. So let's try that. We got 2 minus 1 over k minus 1 over k plus 1 squared. Yes, this is looking really good. Remember, all of this is going to be less than, what are we looking for? We're trying to show that's going to be less than 2 minus 1 over k plus 1. Alright, so I'm not going to write that every single time. I'm just going through because it's a lot of extra writing. But just be aware, that's what we're trying to show throughout all this. How did that help us? Well, I can tell you exactly how that helps us. We can now say we want these denominators to match up. So I can multiply this side by, let's pull out a different color. I want to multiply this side by k plus 1 squared over k plus 1 squared, which is just 1. Any number divided by itself is just going to give you 1. And this side, we're going to multiply by, well, k over k, which is still equal to 1. Any number divided by itself is equal to 1. So if I do that, that'll give us a common denominator to work with. So if we do that, we end up with 2 minus, well, what would this be? This is that times that. So it gives us k plus 1 squared. And this one would give us k. So we've ended up with k plus 1 squared minus k, and they've got a common denominator now, right? They've got a common denominator of k times k plus 1 squared. I multiplied the top and bottom by the same value, multiplied by 1, and that gave us something that's still a little gross. I still don't quite see how this helps us. Well, let's just keep working through things and seeing what we come up with. So for here, I see we got something squared. Maybe we can do something with that. So let's see. Well, we could multiply part of this out. So let's try it. We got 2 minus, I use the bigger brackets this time. That'd be k times k. Well, that's just going to be k squared. And we're going to end up with 2k. And I believe plus 1. Yes, someone can check my algebra on that. I'm pretty sure it's going to work out right. And that's all over top of k plus 1, k times k plus 1 squared. And now we can kind of combine some like terms. We end up with k squared. We got plus 2k and a minus k. That works out to a plus k plus 1, all divided by k times k plus 1 squared. Okay, Whew, really starting to get interesting now. Let's see, what was our goal again? We're trying to show, if I can go back in my last papers, we're trying to show this, right? We're trying to show that this value is going to end up less than that. And we kind of restated our goal over here. We wanted this to be less than that. So let's make sure we're keeping that in mind as we go through. If we can make it look a certain way where it's really obvious what the answer is going to be. Here's what I'm thinking. I'm thinking we pull some of this stuff out. We make it look a little bit easier to manage. Let's try it. Let's say 2 minus k squared plus k divided by k times k plus 1 squared. And we're going to kind of pull this out a little bit, subtract a 1 over k times k plus 1 squared. Now, if we do that, some interesting things start to happen. Some very interesting things start to happen. Things start to cancel out. Things start to cancel out really cleanly. For example, we can factor out a k. So that would give us a k squared plus k is the same thing as k times k plus 1. Hope everyone can see that. And that k times k plus 1, we'll notice, is getting divided by k times k plus 1 squared. Let's actually write that on both sides to make sure our equalities line up. That would be embarrassing. Right. So we've shown this. Well, hold on. Wait a minute. I know what we can do here. We can cancel out a k. That's really easy to do. And we can cancel out a k plus 1. We just took one of those out. So what did that leave us with? Well, that leaves us with 2 minus 1 over k plus 1 minus 1 over k times k plus 1 squared. Remember, we're always trying to show that that's going to be less than this. So let's come up here and write it. It's going to be less than 2 minus 1 over k plus 1. And is this a true statement? I happen to feel it's very true. We have the same thing on both sides of the equation. That's really nice. We have this and this. They line up exactly. But then we're taking away a little bit more. We're taking away just a tad bit more than what was shown on this side. So we know that this side is going to be less than this side, and we know that this side is just a little bit bigger than that summation that we were looking for. So if this is just a little bit bigger than this, and this is just a little bit bigger than this, we know 2 minus 1 over k plus 1 is going to be bigger than that summation. So we have shown that this statement is always going to be true for values where k is bigger than 1, and that's what we wanted to prove with our goal. Thank you for watching.